My name is Andrew Sargent, and today I'm going to talk to you about sampling and statistics. First thing to consider is, what is a sample? So in statistics there are two main groups, the population and the sample. The population is the whole group that you want to gain data on, while the sample is a smaller subset of that population that you're actually going to study. And in order to make sure that the data you gather is useful, you want to make sure that you randomly select your sample, so you don't want to only take volunteers to gather your data. You want to have people randomly picked. Another thing to consider is the sample size. You don't want it to be too small, otherwise it won't be able to represent the population properly. So if you wanted to find the opinion of all college students in Michigan, you couldn't simply go to U of M Dearborn and ask only students from there, because it wouldn't properly represent the whole population, which is all college students in Michigan. Another thing to consider is possible biases that can be introduced. The three main ones are selection bias, non-participation bias, and response bias. The first type of bias is a selection bias, and this occurs based on who you choose for your sample. Most commonly, it will result from the sample size that you use, and this results in the sample not being representative of your population of interest. So for example, if you wanted to know whether or not people in Michigan like Coney Island, if you only pick people from Dearborn as your sample, that wouldn't be a useful sample size, because you're only looking at one city. And while, say, people in Dearborn might love Coney Island, people in another city like Canton may hate it. So the data that you gather would then show that everyone in Michigan loves Coney Island, when that is not the case based on who you selected. The next type of bias is a non-participation bias, and this occurs when you cannot contact part of your sample group. And again, this results in data that does not properly represent your population of interest. So for example, mail-in surveys. Odds are, if you use a mail-in survey where someone has to, for one thing, actually read the survey that they receive in the mail and then send it back to you, or do anything more than that, odds are you're not going to get all of the data from your sample, because many people are likely to simply throw it away, and then you won't get their data, and then it does not properly represent your population. The last type of common bias is a response bias, and this happens when people don't answer honestly. It can be the result of survey questions or influence from the interviewers you have asking these questions, and again, results in data that does not properly represent the opinions of your sample. So for example, if you conducted research over the phone and asked people questions such as, do they think government funding should go towards research for children with cancer? Even if someone doesn't believe that money should be spent on that, they may feel that, oh, I should say, yes, money should go towards research for kids with cancer, even if they don't actually feel that way. They may say what they think doesn't make them look like a bad person. Another thing to consider is your margin of error and confidence intervals. The margin of error is a way to show how the data that you collect may differ from the population of interest. In other words, how many percentage points off from the real population is your actual data. And the most common margin of error used is a 95%. And the way to calculate that is 1 over the square root of n, where n is your sample size. Tied in with that is a confidence interval, and that represents how confident you are that if you repeated this research, that it will produce intervals containing the population proportion, which is represented as p. And again, the most common interval used is 95%. And the way to calculate that is p hat plus or minus 1 over the square root of n, where p hat represents the sample proportion, and again, n is the sample size that you're using. Now, an important part of this is also your sampling methods. In order to say that you have good sampling methods and, as a result, useful data, they need to be random, which means you're not only taking volunteers, you're taking people, you're not picking and choosing who you use in your sample. They also should be independent and identically distributed. What this means is, for it to be independent, one response isn't going to affect another. So if I were to choose A in the survey, that wouldn't make you want to choose B or C. As for identically distributed, that means that all the surveys that you use or the methods you use to collect your data are the same. And you're not giving out, say, version 1 to me, version 2 to you, where the answers are different or in a different order. You want things to be exactly the same, so that way you don't affect your data or bias it in any way. And another thing to consider as far as biases go is you want your questions to be neutral. So what that means is you don't want to include anything in that question that's going to make someone think a different way. So you don't want to include anything like, because something's not illegal, do you think this? Or because research shows that something is harmful to your health, do you believe this? Because that can bias individuals' answers and may change the way that they actually answer your questions differently from what they actually believe. Finally, let's talk about the different types of research studies that you've got. So there are two basic types, and those are observational and experimental. Observational studies involve simply observing the participants. So you don't assign any treatments, you're looking for, say, their opinions, behaviors, or any outcomes. Experimental studies, on the other hand, involve the manipulation of some variable to measure its effect on your outcome of interest. And often you randomly assign participants when doing experimental studies. So most studies involve both explanatory variables and outcome variables. So the explanatory variable is what you're interested in learning what the effect of that is. So what is the effect, in the case of what is the effect of X on Y, the explanatory variable is X. The outcome variable is what is being affected and gives you the outcome that you're studying. So in this case, it would be the Y. Another thing to consider is confounding variables. They need to be considered because they both affect the response variable, the outcome variable, and they're related to the explanatory variable. And that can affect your data, and these most commonly occur in observational studies. Now, a good way to try and avoid this is through randomization, because it helps to reduce the effect of that confounding variable, and the best way to do that is to randomly assign people. So say you're doing a medical study where you're giving one group the actual medication and you're giving the second group a placebo. You don't want to have someone picking specifically who goes into what group based on anything. Even if you think, oh, this person has this health issue, if this medicine really does work, it could help them. You don't want to assign people to groups based on anything other than things being random. Otherwise, you can bias your data and thus give yourself data that does not properly represent your population. This has been Sampling Statistics. I have been Andrew Sargent, and thank you very much for watching.